Hey everyone, so this video is going to be a little bit longer. So what I'm going to end up doing is just for the most part telling the answer and then a brief overview of what equation was being used. So for this first one, pause video work cell phone, go in a second. All right. So question one, they want the net force of this object. The answer is going to be 0 newtons, mostly because it says constant speed. So again, once we know it's moving at a constant speed in a straight line, we know the net force has to be equal to 0. Here's the next one. Pause video work cell phone, we'll go in a second. All right, so they want us to figure out which ones is false. So one good way is to go through all the choices that don't make any sense. Like for example, this one, same force. So the force required to pull it has to be balanced by the frictional force opposing it. Frictional force is based off of two variables: the material, which is the mu term, which here is the same, and the Fn term, which here is the same. So the frictional force will be the same. This will be out because they're the same material. Um, this is true because it's the same mass. Um, this is also true because of the fact that same friction force, and pretty much the same thing here. So the only one that is false is this one, that the magnitude of the frictional force is greater for the block on the right. The amount of material on the ground does not affect how much friction it experiences, just mu and Fn, the material and the normal force. Here's the next one. Pause video, work yourself. I'm going to go over in a second. All right, so pretty basic plug and chug. Ff equals mu Fn. The key thing here is just to know which terms go where. The answer is D, 0.05. It honestly makes sense because for the most part, the coefficient of frictions that you end up seeing will be less than 1. All right, here's the next one. Pause video, work cell phone, I'll go over in a second. All right, here they want to know which of the objects accelerated. Best answer is choice D, 2 and 3. Moving in a circle at a constant speed. Remember, only straight lines at constant speed count as being in equilibrium. So moving in a circle at constant speed does not count. And then being a projectile, we all know that projectiles accelerate. So again, constantly accelerating. All right, here's the next one. Pause video, work self, and we'll go over in a second. All right, I couldn't really get everything in there. So this one has the answer is A. So best way to do this is to draw an FBD. So we have a frictional force acting on this, going in this direction. We have a gravitational force going down as mg. We also have a normal force, which is going to be equal to this mg because of the fact that vertical forces are balanced. There's going to be a tension force here. On this one, there's just going to be a tension force going up. And there's going to be a 3 mg gravitational force going down. Now, I can't say that these two are balanced because of the fact that we do know it's going to accelerate. So in addition to these FBDs, I like to draw my direction of acceleration. Boom, boom. This one goes to the right. This one accelerates down. Because I'm looking for everything going on, we know the acceleration of the system. So I'm going to treat it as one single system. So sum of the forces is going to be equal to ma, where this is the total mass. The forces in the plane of acceleration is going to be ff, which I'm going to just quickly go and plug in as mu times mg. So that's the frictional force. Because it's going in the opposite direction of acceleration, I do minus. Then I have plus ft, because it's going in the same direction as the acceleration. I have this ft, which is going in the opposite direction of this acceleration, so that's minus ft. And then this goes in the same direction of the acceleration, so plus 3mg. And all that is going to be equal to the total mass, which is m plus 3m, which is 4m, times the acceleration. Everything kind of got smushed together. I'll start cleaning things up in a bit. So we have negative mu mg plus 3mg equals 4m times 0.6 g. The nice thing is that every single term has an m and a g in it, so I can drop them all out. So this ends up being 3 minus mu. I'm just moving things around because I hate that starting negative. 0.6 times 4 is 2.4. Move things around, and we get mu is 0.6. All right. So this one I did go into a little bit more detail, only because multi-mass systems, Atwood machines, modified Atwood machines, they can all be really tricky. All right. Here's the next one. Pause video, work self, and we'll go over in a second. All right. They want the direction of friction. Friction always opposes motion. Boom, easy enough. Question 7. Pause video, work self, and we'll go over in a second. All right. The answer for this one is C. The way we're going to do this is plug and chug into the equation. Fg equals mg. We have the mass, we have the weight, we could get the acceleration. All right, question 8. Pause the video, work self, and we'll go over in a second. All right, the answer to this one is 50. The way we go about this, pretty much Fg equals mg, or F net equals ma. It really doesn't matter. Would have gotten you the same answer with the mass and acceleration. Question 9. Pause video, work self, and we'll go over in a second. All right. This requires you to look on the reference table for what dry asphalt is, what the coefficient of friction for that is. We're going to use FF equals mu Fn. Because of the fact that it's moving at a constant speed, that means we're going to be using kinetic in this case, which I don't know the coefficient off the top of my head. We have the normal force, so that's the answer here. The 2 meters per second does not matter. It's just a red herring. As long as it's constant speed, that's all that matters. So the answer for this one is 40 newtons. All right, just plug and chug. The key thing was just to realize that that's what you're looking for, but honestly, your sensors should start going off the moment you start seeing materials, dry asphalt, concrete, everything like that. All right. Here's the next one. Pause the video, work self, and we'll go over in a second. All right. So this one is a little bit more involved. So again, probably going to take a little bit longer to go over this one. We know the drill. First thing that we have to do is draw an FPD. So we have our box. We have the force of gravity going down of mg. We have the normal force. Now I'm not going to say that this is mg because I do know that there's going to be a vertical component of the tension and a horizontal component of the tension. I'm not going to write it in here, but we all know what these components are. This one's going to just be t sine theta, and this is going to be t cosine theta. And this one is going to be the frictional force. So they want the acceleration of the block. What I'm going to do is, that's step 1. Step 2 is going to be do my sum of the forces, and I'm going to do it for both directions. In the y direction, I know that the sum of the forces will be equal to 0. So I know that Fn plus the y component, which I already said was t sine theta, is going to be equal to mg. So I know Fn is going to be equal to this monstrosity of a expression, mg minus t sine theta. Based off of my choices, it doesn't look like it gets any nicer than this. Then I'm going to do the horizontal component, fx. Because of the fact that I do know it's accelerating, I'm not going to set it equal to 0. I'm setting it equal to ma. I'm looking for a. Then what I'm going to do, I have tx, which is t cosine theta, subtracting the frictional force equal to ma. T cosine theta, I have to replace the ff with mu times Fn, which I already have here as mg minus t sine theta. Starting to lose some room here. And I'm also going to divide by the mass because I want to get the acceleration by itself. So I just find the choice that matches this a bit. Might take a bit. I think the answer for here was choice A. All right. Here's the next one. Pause video, work self. I'm gonna go over in a second. All right. Here they want us to. The answer here is going to be C, because of the fact that we always know that kinetic friction. It's always easier to keep an object moving than it is to start it moving, and this is shown by the fact that the kinetic coefficient of friction is always less than the static coefficient of friction. All right. Question 12. Pause video, work self, and we'll go over in a second. All right. Here, they want us to figure out the force of static friction acting on the box. So, uh, if the fact that it remains at rest means that the forces have to be balanced. Always remember that Newton's first law must hold true. If an object's at rest or an object's in equilibrium, the forces must be balanced. I don't care what the equation says, the forces must be balanced. That is a key component to forces. All right, here's the next question. Pause the video, work self, and we'll go over in a second. All right, so for 13, they want the force of friction acting on the mass. The answer is going to be B. The way we end up doing this, uh, we end up, it says it's moving at a constant speed of 6 newtons, so we know that the force has to be 6 newtons to the right. All right, 14. So here's the next one. Pause the video work self, and we'll go over in a second. All right, they want us to know, if it was frictionless, what would the acceleration be? The answer to this one is going to be D. We literally just do plug and chug into F net equals to ma. Oh, we have the mass, we have the force, easy peasy. All right, here's the next one. Pause video, work self, and we'll go over in a second. All right, so they want us to figure out which one has the smallest friction. Well, the answer here will end up being choice C. So again, we just compare, we use the equation FF equals mu Fn for each of these choices and pretty much just see which one has the lowest, nothing really crazy. And that's it for this first part of the problem set. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.